Hey guys, we are working on direct variation today. So what we're going to be doing is you're going to plug in these vocab words and then we're going to get started. So a direct variation is a relationship that can be represented by a function in the form of y equals kx, where k cannot be 0. So this form is really important. As you can see, there's nothing being added or subtracted to the kx, so it's just y equals some number k times x. So k is called the constant of variation for a direct variation equation. So what we're going to be doing is for a and b, we're going to be stating whether the equation is a direct variation, and if so, what is k? What is the constant of variation? Okay? So in order to do this, we're going to solve for y. So for a, in order to get y alone, we need to divide by 7, and we get that y equals 2 over 7x. Now, just like we stated before, this is in the y equals kx form because there's no number being added or subtracted to this term on the right-hand side. So, yes, direct variation. And our k equals 2 over 7. Okay? So the same thing for b, we're going to solve for y. So in order to solve for y, we need to get 4x to the other side. So we subtract it, and we end up with 3y equals 8 minus 4x. Now we have to get rid of this 3, so we divide 3 on both sides everywhere. So you get that y equals 8 over 3 minus 4 over 3x. Now, as you can see over here, we have this term that's being added to our 4/3 x, to our negative 4/3 x. This term means that it is not a direct variation. Do we see the difference between A and B? One has more than this one term on the left and the other one doesn't. Okay? So, next up, example 2 says that suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y? So we know that our direct variation equation is y equals kx. Now in this first line, we know that y is 35 and x is 5 when they vary directly. So we're going to plug that in. Y is 35, k, and then x is 5. So in order to find this constant of variation, we need to get 5 to the other side by dividing, and you end up with 7 equals k. So now if I want to rewrite this for this direct variation equation, we get that y equals 7x because I'm just plugging in 7 for k. So the last part, so this answers the question. This is the equation that relates x and y directly. My last part of this says, what is y when x is 9? Okay, well, we're going to plug in 9 for x. 7 times 9 is 63. So y equals 63 when x equals 9. So those are your two answers. Here's the equation, and here is the value of y when x equals 9. So I want you guys to try this one on your own. Again, you're plugging in y and x into your original direct variation equation to find k, and then you're plugging k into this direct variation equation to solve for y in this case. Okay? Okay, so these are examples of direct variation equations. They are going to look like this, just with your slope being different depending upon what your k is. So just properties of direct variation, we're going to write right here. So direct variation equations always pass through 0, 0, which is the origin. Okay? They always pass through this middle of your graph, which is your origin. Okay? The next property that direct variation equations always have is that k equals the slope of the line. And again, the equation for direct variation is y equals k x. 2 more problems for you guys in the same problem, okay? So these examples are asking us to use the table to say if y varies directly with x. If it does, then we write an equation. So the way that you're going to do this is always calculate y over x and see if they're all the same between all 3 coordinate points. So y over x is going to equal 6 over 4, which simplifies to 1.5. It's also going to equal 12 over 8, which simplifies to 1.5. And lastly, 15 over 10, which simplifies to 1.5. So if we notice, these are all the same, which means that it is a direct variation, which means that my equation is y equals kx. K is 1.5, and x stays as it is. Okay? So we're going to take this now over to the right-hand side for b, and we're going to do the same thing. So y over x equals, the first one is 3.2 over negative 2, which simplifies to negative 1.6. Our second coordinate point is 2.4 over 1, which simplifies to 2.4. And our last one is 1.6 over 4, which simplifies to 0.4. As you can tell, none of these are the same. So this is, we can say that y does not vary directly with x. So we can't write an equation like we did over here because we don't have the same constant direct variation, constant of variation. Okay, I hope this makes sense, guys, and I will see you soon.